Right, that could be good. Make the file a little smaller. Okay, so remember, so constants carry through, addition and subtraction, you just handle the x part derivatives as they come, and everything else carries along through. Feel free to talk to your neighbor. It's always weird when it's silent. Are you ready to look at it? Okay, so let's just take the first part. You're going to take these kind of term by term. That's what subtraction carrying through allows you to do. So the first term, 5, 6, that stays in front, times, what would be the derivative of x cubed? 3x squared. Minus, that carries through, 1/6, that carries through. What's the derivative of x to the minus 2? Negative 2x to the negative 3. Okay, so now we just need to clean everything up. So 5, 6 times 3.
23, or 6.
5 halves? Yes? Or 2.5? Yeah. When we get to the business parts, really everything should be in decimal. But when we're doing this part, typically math people like fractions because fractions are precise and decimals are sometimes rounded. So you'll see me write fractions a lot. X squared minus, well, negative times a negative, positive 2/6 is 1/3, x to the minus 3. Okay, so when you're doing these, just, if you find that you've multiplied by a constant, just go ahead and write that down, and then write down the derivative, and just go term by term. If you've got a minus sign, then write the minus sign, and the constant, and then write the derivative, and then clean it up. Any questions? All right, so now I'm going to mix everything up. So we've covered power. So we've covered the constant rule, which says the derivative of any constant is 0. Any constant anywhere by itself is 0. Yes.
How come you wouldn't just times the 3 by 5, 6?
You could, and you get 18/6. Wait,
Okay.
I mean 15/6, and then you'd have to, simplify. It generally is a good rule of thumb to simplify fractions, multiply fractions first before multiplying. Because when you multiply, you get bigger, and then trying to simplify bigger is harder. So it's always easier to simplify when it's smaller. Okay, so constant, derivative of constant, always 0. Derivative of the power rule, bring the exponent down in front, bump that down by 1. Doesn't matter if it's an integer, positive, negative, fraction. Could I do it if n was 2.7? Sure, same pattern. Constants, multiplying by a constant, carry through. Adding and subtracting, carries through. Okay, so let's do several different examples here. Find DDU of 5u squared minus 6u plus 3. Prime x. So these are all several different examples. For f of x equals this one pretty exciting. Are you excited? Wow, it's exciting. It's a little bit of everything. You guys look so excited. Those are two different ones, yeah. So I'm writing a list of problems. So for all of these, find the following. And I have hints for the last two. So let's just talk briefly why I made those hints. X minus 4 quantity squared. Does that follow this pattern?
No.
That's just an x. That's an x minus 4. So the power rule does not apply directly to this. In several days we'll see how it sort of does, but not directly. So you have to FOIL that out. What about this one, 9x minus 5 over x? Does that follow any of these patterns? No. But can I pull apart that fraction? 9x over x? Yeah. And then you'll rewrite it and it'll work. Okay. So in this case you have to FOIL, and in this case you have to break apart the fraction. So go ahead and give that a go.